Okay, so another man with over 25 years experience in the market is Cambium's very own VP of millimeter wave products, Anthony Holmes, who joins me now.
Hello, Brian. Nice to see you again.
Hi, Anthony. Nice to see you. Now, as you know, you've had the pressure put on you as being dubbed as the man who brings the magic to the portfolio. And as Rad said, you're going to be talking about digital transformation in relation to the 60 gigahertz cnWave. So look, we're on schedule. I'm getting brownie points, I think, from Lisa. So I'm going to let you go. But before I do, can I remind people, please get those feedback forms in very quickly if you haven't already done so. But with that, over to you, Anthony.
Thank you. Okay then, right. So the demand for multi-gigabit solutions has never been more important as people learn to rely on it more and more. Wireless bridges to bridge that gap to ensure ease of deployment and connectivity quickly and reliably. We're going to take a look at the tools, products we have for enterprise and how 60 gigahertz and specifically Telegraph technology in Cambium cnWave products allow you to think out of the box. Take the example of steel as a transformational enabler. Steel has made it easy to build cities. It's now the basic building blocks in some of many diverse applications. First, railways enabled intercity commerce and travel. Both made it cost-effective and easy to expand. Well, guess what? I'm going to show you or tell you that 60 gigahertz is a transformational enabler. It will enable you to integrate and expand networks and connectivity in many different applications. 60 gigahertz makes it cost-effective and easy to expand connectivity. Think of 60 gigahertz as the new basic construction material for you to build your high-quality, affordable networks and deliver gigabit access to your customers. Here are the players. The V5000, it's a distribution node. V3000, high gain. This will give you 60 dBm, 55 dBm a high gain antenna. We have a field swappable antenna for this radio, so a little bit smaller and compact. And then we have the V1000, which even though it's the size of your hand, will provide a gigabit to your customers. So let's look at the different topologies. So PTP, right? Basic topology that you'll see. You know, we've got lots of products out there, sub-6 products and millimeter wave products as well, you know, your license-based products. But now we have a 55 dBm in ETSI, 60 in FCC countries, available both on the V3000, and then you've got a 38 dBm EIRP product in the V1000, providing PTP access. You could imagine these being a nice replacement for 5 gigahertz if you're in a noisy environment. And we see this used quite a lot for building to building, bridging that gap. We've got deployments in railway stations, for example, where, you know, laying fiber or cables across a track is just not viable. So you could use one of these little links to get across and provide that gigabit access. Each one of these V3000s and the V5000 has the ability to power Wi-Fi off these. And we see these often used to power Wi-Fi products, cameras in the field. And they then are able to backhaul that data straight back to a centralized point or your NOC. The V1000 is the way around. You can actually power, we've seen this where the Wi-Fi devices power the V1000. However, it's still the backhaul device. So it can get that Wi-Fi information back, or the camera information back to that centralized point. Just briefly, as far as throughput is concerned, you can see we've got various ranges here from the V1000, which is around about 100 meters, will give you a gigabit, up to maybe 200 meters will give you a gigabit of data, to the V3000, where right up well over a kilometer, even 2.75 kilometers using channel 4, you can get around about 3.8 gigabits per second. That's a bidirectional rate. I'm going to show you a little bit about channel bonding in a second. So I just wanted to expand on that with the point-to-point. And this is probably one of the fastest 60 gigahertz links that you're going to find at the moment. So this is our trial link in Ashburton, where we're playing with channel bonding 2. This is where we take 2 of those 60 gig channels, bond them together, and able to send data over them. As you can see from this, we are getting 2.6 over 2.6 gigabits per second in each direction, and that's a bidirectional throughput. So that's 5.2 gigabits per second. And this is on channel 3 as well. And as you saw before, that 1.2 kilometers is well within that range to get that MCS 13 as this is. Then I want to look at the next one, point-to-multipoint, or the MicroPOP approach. I say MicroPOP approach because with the 60 gigahertz technology, unlike something like EPMP or Canopy, where you put it on a mast and you deploy over it, you sort of view over a wide arc, many subscriber units. This is about a micro point of presence deployment, where we're looking at serving 30 subscribers from a single point. So it's very simple deployments can be done this way. Great for that. Now, if you look at this, what we have here, we have a bunch of buildings that they want to deploy data to, and then we have another bunch of buildings here, but they're actually non-line of sight. And the knock is around about here. This is where the office is. So we've got to get to these. Now, things to consider when you're doing point-to-multipoint and doing the MicroPOP approach, line of sight from a single point can be blocked. So you have to take that into account and have to get around that. Range can limit you as well. 60 gigahertz, you saw on the point-to-point. Range is in the hundreds of meters, but you can extend that if you use a high gain radio. Redundancy and capacity is fixed when you go for a MicroPOP approach. All these, whilst they're limitations, they can all be overcome. Here we have the one distribution node transmitting out to those buildings. This is basically using the V3000, so it can bridge that 600 meter gap very easily and still provide that to 1.8 gigabits per second to each one of those buildings. Then to get to the non-line of sight buildings that we had, we're actually using a point-to-point device to extend the reach of that POP from the knock right to the center of that distribution you want to get to, and then we're then able to use the V1000, a very cost-effective, high-quality, cost-effective product to give a gigabit per second capability to each one of those buildings. So you can see that even with a MicroPOP approach, you can use the different products together to create these links. Then I want to talk about distributed networks. This is really where the Telegraph technology in 802.11ay comes into its own. And this is where you're not going from a single point, but you're spreading out your network to cover a wide area. Here we have a holiday home, which is each one of these buildings or these holiday homes are demanding gigabit rates. They want to see that. They're going to share that capacity, but each one of them want the capability of being able to get hundreds of megabits, even a gigabits per second. So how do we go about that? So what we do is we distribute DNs throughout the area we want to cover. There's around 14 in this design to cover this. We then look at the CNs that are deployed in there, over 250 CNs, each one of these going to the individual buildings. We are then able to link each one of those up. And what we have here is not only have we been able to link each one of those 250 units together, we've also created redundant paths. So the DNs are actually talking to multiple DNs. And therefore, you actually get the meshing technology is able to work. So what we actually have here is the ability that if any one of those links goes down, we can reroute the access and keep those CNs able to communicate. We've recently brought in a beta, actually, where those CNs can actually have a secondary DN. So not only are we protecting the DN backhaul path back to the POPs, we're also able to give that CN the choice to actually jump onto another distribution node if its DN goes down. Basically, all this technology enables you to have a very reliable network. At the moment, this design has a single POP. Every POP that you have, point of presence, offers you around about 7.2 gigabits per second capacity. Basically, adding additional POPs provides you redundancy if that POP goes down, but it also provides you capacity. Each POP that you add enables you to have that 7.2 gigabits per second. So what you'll see in these distributed networks is a number of POPs able to share that capacity. And again, the telegraph technology underneath is all dealing with that totally invisible to you as an operator or a provider. It's all hidden, and all that technology, all that complexity is invisible to you. It just sorts itself out. I want to then look at growing that, but this is, you don't have to have large scales here, but these building blocks actually then provide the footprint to actually get into cities, smart cities. And we've actually got a smart city deployment going on at the moment in the US, which I want to show you a little bit about. Now, what this is the city wanted to actually provide a digital infrastructure to support cameras, Wi-Fi, residential and business broadband opportunities throughout the city. So we went about it with cnWave. Now, to do something like this, you'll plan it out. And now you'll see the plan here. We have the cyan little tiers are the actual clients that these are the businesses and the residential units that we were trying to get the data to. The blue ones are the distribution nodes, which are used to not only backhaul the data to the POPs, point of presence, which are the yellow ones, but also to provide a point to power Wi-Fi access points and provide Wi-Fi capability throughout the city. So that's the planning stage. And what we actually find is that now the image on the right is actually CN Maestro managing that network live. So we've actually got a live network in a city providing Wi-Fi access, providing cameras, providing that backhaul for those customers. On a street corner, someone with a phone was getting something like 200 megabits per second through this network. So this is the kind of scale you can go from a point-to-point device to point-to-multipoint to distributed mesh networks to providing access to a whole city. These are the building blocks that you can use to construct your networks. So not only can we go to that scale, I also want to sort of mention again that how this can be utilized for the building to building or campus. So if you've got a private network that you want to cover, again, very simple to install. These distribution nodes are able to spread your network throughout an area. And then looking at this, where we have Wi-Fi coverage to be able to backhaul that Wi-Fi, very noisy environment, a train station, lots of metal moving around. By linking distribution nodes, and each one of these distribution nodes again is powering that Wi-Fi unit and then backhauling that Wi-Fi data back to the centralized point. You're able to link these together and get you a reliable network to be able to deliver that Wi-Fi back. Now, this can be used in a rail yard, it can be used in a dockyard, it can be used we see these in warehouses. So lots of different ways of being able to provide that Wi-Fi connectivity. Simple management. This is key to all this, is how do you manage this? We utilize CN Maestro heavily on this, and you can use Maestro X or you can use Maestro Essentials. Now, this can be again in the cloud or it can be on-premise. Basically, one Maestro client can manage multiple networks of cnWave, from very simple things like point-to-point devices. So you can have a number of point-to-point devices on here where the controller is all on board the actual device itself. You can manage at the same time multiple point-to-multipoint links, these MicroPOPs, where you have a single MicroPOP site. And again, the onboard controller and controlling all these is all built into that POP device. Or as you grow, you can actually have, you can take the end-to-end controller off and have it as a separate managed unit inside your server room or in a reliable, suitable, safe place. Now, having this end-to-end controller external enables you to actually control multiple POP sites. As long as these POP sites are on the same layer 2 addressable range, they can all talk to that end-to-end controller, and basically you have that you can actually control not only all the devices on there, but also you've got redundancy as well. If any one of those POP sites goes down, internally everything is rerouted to the other POP sites. If you're using some IPv6, for example, you can actually use BGP routers as well, and these will zone your network automatically for you. And again, this is all invisible to you. As well, the network itself does not have to be IPv6, so you can talk to clients using IPv4. That's not the problem. Internally, it's all IPv6, and that is a huge benefit to you. Basically, using layer 3 routing, you don't get any broadcast storms, the loops you won't suffer from, and you're able to change direction and change route very quickly and reliably. Network planning tools to make it easy to plan your networks. We're using Link Planner as the basic tool for this. As I'm sure many of you know and love Link Planner, you were able to not only configure your network on here, to take a look at the performance that your network might have, create bombs so that it's simple to order your network once it's complete. So it's all in there for 60 gigahertz as well. On top of that, we have the advanced network planning tool. Now, this is all about how to do these mesh network designs. This is able to, from a very simple network to a complex distributed network like this, where we've actually got hundreds of homes in this, but they could be caravan parks, it could be positions inside a campus, whatever it is. And it's able to use LiDAR data and able to identify where to actually position your distribution nodes. Of course, recently, if you've been looking at Cambium's website, you'd notice that CN Heat now fully supports the 60 gigahertz range. And with CN Heat, you're able to very quickly take a look at these designs and see, have you got that line of sight? And therefore, you can utilize that with Link Planner, with the Advanced Network Planner to design these networks very quickly. So I just wanted to briefly go through these turning the possibility into reality. So standard-based technologies enabled us to make these affordable, high-quality products in order to give you these building blocks, to give you these construction, these things to enable the construction of your networks. Not all wireless devices are the same. Basically, using software, these are software-defined radios, and we're optimizing these to perform in different environments, whether it's point-to-multipoint or point-to-point, to maximize the use of those devices. Basically, whether it's for distribution, for long range or short range clients, you need a mix of these, as you saw, to be able to do point-to-point, point-to-multipoint, and distributed networks. You can use these in multiple modes, whether it's point-to-multipoint, point-to-point, or distributed networks. And whilst you're not, one of the most important things we've tried to do here is make it simple for people who may not be used to doing wireless, that may be doing fiber, may be used to, they don't want to climb towers. They're used to doing Wi-Fi devices. So we're trying to make it as simple as possible to enable you to do that without any prior knowledge of fixed wireless access design. So we have obviously the deployment tools, whether it's LiDAR, whether it's link planning or mesh planning, but we've also made the installation easy and simple. So it's just like if you were deploying a Wi-Fi AP. You go along, plug it in. The actual end-to-end controller downloads the configuration from a centralized point. So the installer doesn't actually need to do any of the configuration. It should be done automatically for them. And then on top of that, we use cnMaestro to manage the network for you. Now, whether it's a simple point-to-point device or a point-to-multipoint device, it is all done in one place. And of course, along with the cnWave products, you can manage your your matrix products or your pilot products or your PMP products, all from the same place. So with that, just one final reminder: these are the products that we currently have. Cambium is developing more and more to enhance the portfolio, to make it simple for you. Obviously, software is constantly being updated, new features added all the time in order to make it simple and easy to deploy this software. And with that, my time is up. So thank you very much. And is there any questions?
Hi, Anthony. Yes, we've got a couple of questions for you. First one is, how well does mesh work in large networks? Is there an overhead? And what about convergence times?
Okay, so the mesh technology we're using is called OpenR. This is the same technology that Facebook use in their large data centers. It basically is how they transport all that data that people have with Facebook around the Ethernet network. They actually developed it originally for Wi-Fi. For Wi-Fi, I suppose, 802.11ay. Now, what actually we've got here is a layer 3 mesh. So it's not layer 2. You haven't got messages being squirted and passed around everywhere. The actual layer 3 mesh, each one of the nodes knows what other nodes are doing. They know what they're connected to, and it is all self-healing. So as soon as a link goes down, within 250 milliseconds, that's detected, and the convergence time is pretty instant, and a new path is created. If you need to go to a different POP, that can also be done as well. So I would say convergence is around about 250 milliseconds, something like that.
Okay, and the other question I have for you is, can you support layer 2 IPv4 networks?
Right. So that's a question quite a lot of people ask with this technology. Whilst internally we use IPv6, IPv4 is a button click away. You basically just say, I want to do layer 2 bridging, and all those modes are in place. That includes VLAN tagging, all the Q&Q, S tags, C tags, everything you might want in a layer 2 network. So that's just a button click away. It's very simple to configure.
Anthony, thanks very much for the presentation and for taking those 2 questions. I'm going to move swiftly on to our next presenter. Thank you very much.
Bye.